Welcome to the Great MT Reckoning April 2002 lecture, and thank you for joining and giving me the opportunity to present my view. I hope you will find something useful. Today I'm going to discuss the state-of-the-art MT technology objectively and hope to answer some complex questions which professionals in our industry of translation, localization, artificial intelligence, neural networks often have. These questions are difficult to get answers for due to the complexity of the issues and the overwhelming hype of AI. The presentation was given twice, last year as EU ATC webinar and this spring as Gala webinar, but then I will limit it in time, and this time I'm not. Also, there's new information that has been added since then. The presentation will take about an hour and you can replay the recording and of course email me with questions. This content is for everyone interested in the practical application of the modern MT technology in the professional environment. Customers, translation service providers, both companies and freelancers, expert linguists, project managers, beginners in the engineering, and also anyone who wants to find her own place in the new world with new professions, which we also are going to mention. On the slide you can see a screenshot of the MIT courseware announcement, "The hype is real," saying that today, when a lot has been said about machine learning, data processing, data modeling, analysis, and simulation, when you are trying to solve real-world problems, it is very important to understand how these technologies should be applied in practice, when and how to use these technologies, and when not to. That's why we will talk primarily about the real-world applications of this technology in the industry. The topic of MT is usually viewed through black and white glasses, or from two different camps of either proponents or skeptics. These two worlds were separated. Scientists were talking to each other, the industry was talking to itself. I'm hoping to take an objective and biased position today. On one hand, I will share our real-world experience. On the other hand, I'll consider the essential facts about technology without going into detail too deeply, outlining the key principles. Let me emphasize that we are talking as insiders with respect to AI and ML. Our team has a dedicated R&D department of researchers and developers, machine learning engineers, and we are doing cutting-edge research in the field. We develop and release our own AI-based products. We just released the Parallel Aligner tool, which is built on one of the latest AI models, LAPSI, language-agnostic bird sentence encoding, and Facebook FAIST framework. We've also ported to Python and published on pyp.org for free the HLEPA automatic translation quality metrics. Further, we have carried out HLEPA customization for particular language pairs and presented this work on recent MT Summit 2021 organized by AMTA last August. More recently, we came up with a novel human metrics for measuring translation quality of MT output, which we called LoGPM. It gives quickly, reliable, and very useful results. I'm saying this not for self-promotion. We are using special dedicated marketing channels and other vehicles for that, but only to emphasize that not only do we have vast industry experience, but also certain knowledge of these technologies. The things we have achieved are concrete and innovative and far from simple. We love this technology, but we don't pray to its artifacts. I'm sure you've seen this slide showing the exponential growth in the amount of information we are experiencing, and the blue bars in the chart illustrate the explosive growth of data. The brown line is the number of translators below is almost flat. Its growth on the scale is not noticeable, illustrating an almost constant number of linguists capable of processing information for translation. Usually, the enthusiastic speaker asks the question, how we can process this growth where there aren't enough translators. In reality, this graph is quite misleading because although there is certainly an increase of information volumes, most of this information explosion is in the form of non-human readable data or visual form of photos and videos, and 99.99% of what's left either does not need to be translated at all or is enough to be simply gisted so that the general meaning can be understood. Information which needs to be professionally translated in the form of long text is created and consumed by people, and the content consuming population is no longer growing exponentially. People's consumption of information has increased, but it cannot grow indefinitely. More than that, people read long text less today than they were before. It is true that the volume of long text for translation is growing, but the actual growth is much more modest than it is shown on this chart. Information explosion has effect on translation, which is often overlooked, but has been mentioned 10 years before by Nicholas Carr in his book The Shallows, What the Internet is Doing to Our Brains. This is famous New York Times bestseller, which I recommend you to read, but the conclusions are: our mind changes. The net, with its connectivity, changes the way we think. Today we're able to consume only much shorter texts. Our attention window is much smaller. The texts have to be much more forceful, accurate, and up to the point, and not only marketing texts. This has important consequences which relate to our industry. Unfortunately, people are not reading more. Average modern person has difficulty to focus on long materials. I'm sure that you, as a very advanced audience, will have no problem with these presentations, of course. But in any case, today you have to create not mediocre but high impact text to get to people. As professionals, we are interested in what is happening with this content as MT deployment spreads. Jaap van der Meer predicts singularity tomorrow, a zero-cost translation, but in reality all the premises in his statement are incorrect, as well as conclusion. The reality is quite different. The closer you are to high quality, the cost and difficulty increases tenfold with each step. We already have all the data. More data does not increase the quality. And for good reason. It cannot become better by design of current AI models. On this slide, you see the results of the survey which Common Sense Advisory made in Q2 last year, surveying leaders of translation companies. As you can see, more than 75% of them on average are optimistic about business growth. It's hard to imagine that kind of growth if tomorrow the production of new translations will cost nothing. Obviously, the universe does not agree with the forecast that we've just mentioned. So the question remains, how is the industry changing when it comes to professional translation? And obviously it is changing. If raw MT costs nothing, which is myth number 1, and post-editing is a cakewalk, which is myth number 2, will clients put out much more content for translation? In reality, the volumes are growing, but the existing clients are not giving out much more sweet content for translation. On the contrary, they're trying to make the current stable volumes cheaper. Because if MT is so good, why spend money on translation? When budgets are cut, all quality concerns are going out of the window. Even smart clients are torn between understanding of the shortcomings of machine translation and the overwhelming desire for savings and speed. It's more difficult for localization manager than ever to make budget owners see high-quality translation as investment and not as expense. As we can see, there is no simple relationship. Very complex currents are formed by many different forces in play. Looking at major trends and what has been happening in recent years, we see that MT enthusiasts are saying a lot of attractive things about neural machine translation. But for every statement on the left, there is serious rebuttal. We all know that MT is applied more frequently than ever, and content translated by MT exceeds by far the volume touched by professional linguists. But at the same time, growing number of customers do not want to apply MT. There are sectors, industries where human expertise is of utmost importance. All large IT customers are post-editing, but some large customers with their own MT ownership of the best MT engines do not apply their own MT on their translations. MT often works so well that it can publish raw MT, yet even when an MT works very well, there is a poisoned cookie problem. MT is everywhere, but the quality is going down. There's no more good data. There are many MT options, but why are there so many engines? Obviously, because none of them is good enough. MT saves a lot of supply chain costs, but MT training and research is so expensive, some companies are abandoning their own MT research and signing up with large service providers, such as Google, for example. Translators have to adapt and change, but translators, as we all know very well, have been always using an MT, so there is absolutely nothing new here. We will simply post-edit, but post-editors are hard to find. There is no sufficiently good post-editing training available, and the reason is wrong post-editing paradigm, which took its origin from the past. We are doing everything with MT now, and the quality of final deliverables is worse than ever. This is one complex landscape indeed. Let's have a look one more time on hype cycle and adoption cycle plotted together. Where are we now? This is not a simple question because there were several MT technologies that repeated this cycle, and I was thinking to draw a superposition of this cycle myself until I saw precisely the same chart in Philip Cohen's book of Neural Machine Translation. I was stunned to see how this chart is similar to what I pictured myself. You see many hype cycles in the past, but as far as the latest MT cycle is concerned, it looks like in reality it runs much slower than the hype because more realistic view is more and more prevailing. Why the signs of disillusionment if AI is so good? Here you can see the XTM Cloud screenshot with MT results from two well-known engines. Amazing fluency as compared to previous MT incarnations. Reads well. Unfortunately, these translations are incorrect. This is roughly what BET translator can do, and there is about 20% of such segments, 20% of translations are completely incorrect, and about 30% are editable. A natural conclusion would be that this only requires a slight touch. Unfortunately, in reality, this is not so easy for a large number of serious reasons, as we'll explain further. On this slide, you see a translator's post outlining experience with MTEPE, and it is in itself a reference point where a translator says that while it's remarkable to see that machine can roughly convey the meaning of most of the text, then still the work, on the opinion of this translator, would have been easy and quicker without MT because of double work of checking repeated segments. Editing MT output is a noticeable and annoying brain drain. Translators are paid less, have less time, and only for that, the end quality will be worse, not to mention meaning transfer errors. And this particular translator has coined the new term monstrosities, and there may be two kinds of those which are different in nature, such as poisoned cookie, which is an accuracy problem, and hallucinations, which is completely imaginary constructions that do not carry any meaning. The problem with NMT is that being fluent by design of most frequent occurrences, even the best proposals are always literal and often incorrect. In his already mentioned book, Neural Machine Translation, Professor Cohen gives an example of a German sentence which is taken from WMT 2017 dataset. The sentence has human reference translation. Professor Cohen runs through several completely incorrect NMT proposals and concludes this section with much better example, which he says is fine translation, even though it is different from human translation. This translation is made by the modern state-of-the-art NMT, and you can check it yourself that current Google, DeepL, and modern NMT provide the same translation. Now, we are human professional translators with education and background and some knowledge, and as we see this example immediately, there are two things that are creeping into the reviewer's mind while looking at this sentence. To check it, I have found the source paragraph of this context. Now, if you read through this paragraph, our suspicion is confirmed. The meeting that the sentence is mentioning eventually did not happen. That's why human translator correctly chose was also planned to cover in the past, and from a wider context of the political knowledge, he was also aware that diskutierte was not just discussed but disputed, a hard contradictory question. Now, as you can see, neural machine translation model used present tense where the meeting is in the future and simply also translated diskutierte as discussed. We will explain why this happened later, but for now let's say that NMT proposal gives an idea of what the source is about quite well, but this translation actually contains two minor accuracy errors, which may or may not pose a risk of misunderstanding and misinterpretation for the certain audiences in certain situations, for example, in diplomatic context. Practitioners see this every day when MT generation is presented to them for post-editing. This, for example, is a response of an LSP to one of the leaders of MT implementation reporting its success in conferences around the world. These reports of amazing successes are great, but production has to deal with reality. Unfortunately, we will have to decline post-editing with less level of MT quality because it turns out by no means less labor-intensive than translation from scratch. This means that MT was unusable to the point where it's easier to retranslate. And also in several files, some kind of abracadabra encountered that is not on the video. We didn't edit those segments. So the realization comes that applying NMT is not so easy because people get understanding of the real deployment problems, and this understanding becomes deeper. Awareness of the real cost of implementation at desired production and process quality level also comes awareness of real technological problems, awareness of fundamental limitations of technology, feeling of the real problems of the industry, evidence of pitfall accumulations, and overall the realization that a self-propelled furnace has not yet been built. Professor Antonian Terral from the Netherlands was the first to debunk statements of human parity. Brave move. He did this with the simplest means of very primitive parameters, lexical variety and lexical density. But are we talking about one or two articles? Nope. We are talking about all of them. Recently, an article entitled Scientific Credibility of MT Research, a meta-evaluation of 769 papers, received an Outstanding ACL Paper Award. It was the first large-scale study of MT research. Researchers analyzed the quality scores of 769 papers from 2010 to 2020 for 10 years. Their conclusion is that pitfalls of research papers are accumulating. The reason is that, unlike in physics, in data science it's very difficult to repeat other people's work. MT researchers use inadequate metrics, and they copy incorrect conclusions and results from each other with groupthink without critical thinking or verification. Gradually, they just copy errors from each other, and over time, MT evaluation worsens. Accumulating pitfalls means that it looks like a lot of results and conclusions have to be questioned. The recommendation that authors are giving is that on every paper, the following question must be asked: is a metric that better correlates with human judgment than blur used, or is a human evaluation performed? The automatic metrics or human metrics made with crowd do not reflect MT quality. In reality, the MT quality is not ideal. When asked if the singularity is closed, we would answer that singularity is not even theoretically visible. We clearly see another wall. As simple illustration, this is what the biggest enthusiasts of machine translation think, in particular the founder of Intenta, discussing GitHub Copilot states, this is one of the recent posts, that the most perfect neural model GPT-3 cannot create anything really new. It is good at combining content already created by humans, but if, for example, tomorrow a new API will be released, until people write code for this API, the model will not create anything for it. The question arises, why do we expect a neural model to be able to generate any translation and create a new translation? In fact, it does generate it, as everyone can see, but in a nutshell, how does it do it? Does it always generate it correctly? How accurately? And where mistakes are coming from? We'll try to answer this question later, but for now we will note that much of the problem lies in the quality the user expects from the translation. The question about what the neural model generates is simply one about the quality of the translation. Some people say, look, it's great, but others say, come on, one error is riding upon another here. Thus, the question of measuring the quality of translations becomes very acute. Two extreme approaches to quality are measure carefully or disregard completely. As of recently, we have started to hear something that was not heard before, that translation quality does not have to be measured at all. The statements are coming such as, let the user decide, you need to measure something else, for example, orders, you don't even know what translation quality is, it'll do just fine. We had a case where consumers like poor quality better. It was literally said, it's too complicated, no one knows how to measure it. And the new one, translation does not have to be accurate. Suspicion that this is being said in order to sell you something substandard and actually something very expensive is not without ground. Common sense calls to verify such claims even if you are okay with good enough quality. Good enough for what? You still need to understand whether you are okay with major errors presented in translation. And even if yes, how many of them can be there? You probably want to minimize your impact on the audience, to maximize your impact on the audience. Even if this is not a marketing material, but the audience are professionals, experts in the field, and deal with complex subject matter expert areas, then there is a need to understand what we are talking about, the need for translation to transfer meaning correctly and comply with special terminology. You also need to assess if the risks of mistranslation and harm are not too high. Today, any material, even the non-marketing material, is to break through the user through very narrow attention window, as we have mentioned before. In a nutshell, there are two undeniable reasons to measuring translation quality. To check if we are making progress, we need to measure quality, which Philip Cohen said in his book, Neural Machine Translation. And if you are a buyer of translation, you need to be able to verify what it is that you are buying. It is not too difficult to take some content and train some AI model, and it will give you some result. Question is how to evaluate what you're getting. And beware the fact that Mechanical Turk, crowd quality evaluation, are biased towards MT because an educated common folk does not see the error and favors literal, incorrect translation over good and correct human translation, which is a proven fact. Quality has to be evaluated by translation professionals and not by the crowd. So the quality is important because if quality doesn't matter at all, if reputation doesn't matter, if it doesn't matter what people think of your business and how they understand your business obviously isn't successful. Buying rotten tomatoes is not a saving but waste of money and reputation. There's also one major philosophical reason to care for quality. In my favorite sci-fi book of brothers Strugatsky, 1 billion years to the end of the world, when scientists moves toward the scientific progress, the universe itself tries to deter and contain him with a series of unexpected events. The phenomenon was mentioned by Albert Einstein. There is a race between mankind and the universe. Mankind is trying to build bigger, better, faster, and more foolproof machines. The universe is trying to build bigger, better, and faster fools. So far, the universe is winning. In the book, Malyanov did not surrender to the universe. He accepted the challenge. As humanity moves through the breakthroughs in scientific progress, we need to resist the drive for simpler, more inaccurate, inadequate translation presented as replacement for correct professional translation because of temptation not to think, not to pay to human professionals for their human work is too big. Today, already admission to translation majors suffers. Students do not believe that translation as profession has future. Translators will be even harder to find. If we don't push for high-quality human translation, there will be no one to produce good translations, and we will see more and more of this, and ultimately only this. Although this is very funny, unfortunately we are talking not about some isolated blunders in a couple of funny screenshots. Things are trickier. Many say machine translation can be used, but gross errors may occasionally occur. This statement is misleading, if not completely wrong, and we'll explain why. For now, let's move on to the question of why the data in the 769 articles about NMT isn't very reliable. One of the main reasons is because until recently, automatic metrics were used to measure MT output quality. I'm sure you heard about BLE as a metric. This figure shows a diagram of correspondence between the BLE score and the Human Translation Quality Score. You can see from this picture that there is actually no correspondence. If we remove 5 outlier dots in the bottom left corner, we will see almost perfect circle, which means that there is no correlation at all. When the MT quality was poor, BLE showed progress of MT training, but now situation is completely different. We will mention the recent research paper proving that. Not to mention the fact that the same BLE number of different systems means different things. The fact that you cannot compare BLE created under different conditions, including different language pairs, the fact that translations with lower BLE are often better. But things are even worse because human judgment is not at all what machine translation researchers have thought it is. The human judgment is not a mechanical Turk crowdsourced evaluation. This is not an evaluation by anyone at all, but a professional evaluation according to certain quality metrics built with customer specification in mind. I was shocked when it turned out that MT researchers were evaluating by just humans using mechanical Turk, meaning that it was selected totally at random. That is, in the early days of machine translation, we had to argue that it was necessary to look at the source text instead of looking only at the translation. Then we had to convince MT researchers that an untrained user, not a linguist, could not properly determine the quality of the translation. For some reason, when we go to a court hearing, we need a lawyer and not try to recruit a guy from the street. When we need repairs of an expensive car, we go to the service shop and not trying to fix it in the garage. With any professional service, we do not question the professionalism specialist, but with translation, it's probably the most difficult task. As the quality of machine translation has improved, and as Google continues to improve its algorithm, a recent study of Google research published in April last year found that the old method of measuring translation quality using the mechanical Turk had virtually no correlation with the professional evaluation of translation quality. The study was based on recent research in the field of professional translation, and the evaluation is based on MQM multidimensional quality metrics. Google has invested a serious amount of money in the human evaluation of large datasets, and already this year the WMT shared metrics task is asking for a comparison of quality metrics with human evaluation by MQM and PSQM. Read more about it in our blog. To understand from a bird's eye view why and how the quality of MT has greatly improved, and why at the same time the singularity will not come tomorrow, to understand where the limit is and what are the limitations of this technology, let's have a peek under the hood of Neural MT. I took some slides from the Professor Peter Solowitz with his permission from his lecture on natural language processing. Machine translation has always been based on the idea of taking the entirety of the language and building a machine to translate on that basis. The semantic approach to describing the rules of the language and building dictionaries has proven itself to be quite laborious and expensive. However, alternative approaches have always existed. In particular, scientists have been breaking down the text into fragments of word combinations, the so-called n-grams, and tried to build a text generator based on how often certain word combinations occur. They took all of the Shakespeare's text, about 1 million words, forming a very recognizable language, and found out an amazing thing. By simply analyzing the frequency of n-grams, if you use quadrigrams, you get an amazingly Shakespearean text. There is something to this idea. It is not necessary to analyze linguistic constructions, but you can work with words usage. The Moses statistical engine was built on this basis, which produced mediocre translation, but the cost of building a language engine did not require a description of all the grammar of the language and its entire vocabulary, which costs about $500,000 per language. You can just take the corpus and build a statistical model on it, and in 10 to 15% of cases, the sentence will be quite good. Another 40% will be editable, For real work, of course, this is not enough. That's what we have been always maintaining. But then in 2016, Tomasz Mikolov, a Czech graduate student, came up with a new way to capture word usages. He invented the word-to-vec algorithm, in which a neural network turns each word into a vector of numbers ranging in size from 200 to 500, depending on which words are next to each other. The following hypothesis was tested. Words that are used in a similar context are probably semantically similar. This hypothesis, which is not entirely true, was confirmed, and it revealed something exciting. The space constructed in this way is a semantic space in a very important way. Not only does it preserve vectors of similar words that are close within that space, but their relationship are also preserved. Consider the well-known example of the vector in which woman relates to the vector man in the same way as the vector king relates to the vector queen. If you subtract from the vector king the difference between the man and the woman, you get the queen. That is a famous example which illustrates this phenomenon. Later, several more and more complex algorithms for generating embeddings were created in order to even better capture word usage. All these algorithms are variants of matrix factorization, whereby a very complex object is represented as a product of two matrices of smaller dimension. But to build good embeddings is only to win half the battle. Language is ambiguous, and the same words can have different meaning in different places in a sentence. In 2017, Google Research released an article, "Attention is All You Need," which described the transformer algorithm, a neural network architecture that takes an input sentence, generates embeddings of individual words, and then captures the position of the word in the sentence and looks at all the words in the sentence to determine which word the current word refers to. There are several such attention heads working in a transformer, each fixing its attention on a different part of the sentence. So this algorithm correctly determines this way, as in the example in the lower right, which word refers to it in that sentence, for example. This is how the decoder works. The result is then fed to the input of the generator, which, attention, generates, it is very important to hear what I'm saying here, which generates the output probabilities of the words in the target language and selects the appropriate words to generate the translation based on the probability of word usages in the corpus. This algorithm has already demonstrated a significantly better results, and even though the mechanics of what I just said is very important, but it's also important to see that the results are even much better than before. And it was so interesting that the world began to talk about the breakthrough in this area, and that this basis model BERT was created. The big model, bidirectional encoder representation from transformers, big models built on these ideas have produced surprisingly good results in text generation, and they have made quite a splash. Then this architecture was scaled up to a ridiculous degree with the hope of achieving better results. Look at this. The model size growth exponentially. In 2021, it's 530 billion parameters. Unfortunately, however, the quality is not scaled as quickly because the complexity and difficulty also grows exponentially. In fact, the closer you want to go to perfection, the more exponentially expensive and difficult it becomes in the world of AI. To halve your current error rate, you need X times more money, with X being the model strength. And language problems are the most difficult to crack. So what is it that we're dealing with? What we've just reviewed should be enough to see something that all the scientists and the engineers know very well. They understand the fact about this technology. This engineering solution does not think. I've heard people question what difference is it, whether it thinks or not. Well, it does make great difference because we need to know how it works to understand the limits, what it can and cannot do. And the limits are: good quality of NT output is not guaranteed. The results, it varies significantly depending on engine, model, language pair, training data, domain, type of content, and many other things. Again, this is very important to understand that the quality is a function of model itself, language pair, training data, domain, type of content, many other things. So if you get the good result from the engine in certain situation, it does not guarantee a good result in slightly different situation. The stars must be really well aligned for particular mechanism to produce acceptable results in particular concrete situation. Professor Peter Zolowitz, at the end of the lecture 5, slides of which we've just visited, said, "It's this just numerology that is trained through the stochastic gradient descent method. A wonderful engineering solution, but it has absolutely nothing to do with all that we know about language, and it's unclear what it has to do with intelligence." He's very politically correct, unclear what it has to do with intelligence. Here's the translation for you in plain language. Wonderful technology, but it has nothing to do with intelligence. Very often we hear more data, better models, and it will improve. But there is one huge, biggest problem of data-driven models, sparsity, and it's worse than you think. The problem is that words are not distributed uniformly in the corpus. The word's distribution is governed by empirical Zipf's law, which predicts that no matter how big a corpus is, there will be very many rare words in it. For example, in Europarl 30 million words corpus, and in fact in corpus of any size, there is a large tail of so-called singletons, the words that occur only once, and there are lots of them. 33,447 words, which are in fact words from active vocabulary of average person, such as cornflakes, mathematician, and Bollywood. Getting larger corpora will increase the frequency of words, but reveal previously unseen words with the corpus, with the low counts. Zipf's law is always cited as the strongest argument against purely data-driven methods. It is therefore incorrect to say that as we take large corpus, we will get unnecessary data for translation. We won't. A human needs to be told only once that Ayushinya is a new kind of fish to be able to use that word in all kinds of different ways. The NMT cannot do this, no matter how big the training corpus is. Sounds familiar to technical translators, isn't it? New terms, terminological research, terminology glossaries are becoming even more important, as well as competent human subject matter experts. Okay, rare words are a problem, but the majority is handled well? Not quite. The deep learning stands on 3 pillars: the data, the code, and the model. Let's go one step further into the mechanics of NMT on already provided example from Philippe Cohen's book. To the left of the example, you will see the word predictions of neural translation model as they are taken from under the hood. Remember, the words in the predictions are chosen according to the frequency of occurrence in the corpus in similar company. For example, in prediction example, the word believe is taken because it has probability 68.4% of occurrence in similar situation in the corpus and chosen over think and feel. This helps to choose the most correct translation on average, but it also gives the most mediocre translation, which becomes problematic with ambiguous words and terms, and of course, there is no intelligence here whatsoever. That's precisely why the model did not use disputed and used discussed in the example to the right, and choose incorrect temporal construction should also focus. Neural network is cleverly choosing most frequent words from the corpus, not most meaningful. Because there is no intelligence here at work, human or artificial, purely highly sophisticated statistical method generating by design most mediocre words combination, optimizing fluency at the expense of accuracy. Again, the NMT optimizes fluency at the expense of accuracy. So the challenges of neural machine translations are poor out-of-domain performance, hallucination, the output is fluent when completely inaccurate, unedited MT is a trap. Fluent does not mean accurate even in domain. Low resource language problem. Noisy training data quickly leads to significant quality degradation. NMT learns to copy well, but with noise it's learning bad things. Poor performance on rare words, terminology. Neural MT models are not very interpretable. The answer to the question why the small changes in training data lead to different model decisions is buried in large matrices. There are no obvious knobs to turn and kinks to straighten. Cohen. Fluency is good, but not ideal either. Lexical choice, caused by ambiguous word senses as well as complex semantic relationships, as expressed in prepositions and pronouns, are still a major concern for MT today. In fact, this is exactly what the MIT article said right after GPT-3 arrival. The greatest trick AI ever pulled was convincing the world it exists. That's because the GPT-3 is amazingly fluent, but it doesn't have a grain of intelligence. This trick, of course, was pulled by humans. We tend to humanize objects around us. For example, primitive peoples humanized the sea, wood and stones, and now we do the same to machines. Saying that AI exists is a cargo cult. It's like dancing around a plane made of straw and hoping that the god of helicopter, in which white people used to bring coke and cigarettes, will solve any problem, such as preventing a hurricane. There are more recent and more scientific reviews to that. On October 2021, the Journal of the Institute of Electrical and Electronics Engineers, Spectrum, published an extensive collection of dedicated articles collectively entitled The Great AI Reckoning. I do recommend reading the entire collection, but you can see that even the titles of many of those articles are quite telling. The turbulent past and uncertain future of artificial intelligence. 7 revealing ways AI fail. An inconvenient truth about AI. Deep learning diminishing returns. Many will remember the thought experiment in which 100 monkeys sitting at pianos could produce Mozart melodies in 100 years' time. Now we have managed to control probabilities better, but as Alicia Burkhardt from DFKI said, MT isn't a parrot, a clever parrot, but still a parrot. A parrot can be useful, but you have to keep its limitation in mind. Example of GPT-2 primed with Bible give you Ninja Master, Virology, and other such funny things. Here's another post of one of the Intento founders who is mocking alarmists of AI apocalypse, saying that we should show this picture of similarities between parrot and machine learning algorithm and suggest to use matrix multiplication instead of AI to alleviate their concern. I agree completely. We shouldn't say AI, we should say matrix multiplication. That will tell you the more precise picture of technology that we're using. Antich says that this picture describes the current and foreseeable status of AI a little bit more than completely. The similarities between a parrot and machine learning neural models are: both can learn to generate random phrases, both do not understand a thing in what it learns, often says total rubbish. After the tsunami of hype of AI, it came as a shock to some that complex self-training AI chatbot was observed to drift snap on its own to make racist remarks, so it had to be shut down. The phenomenon of NMT hallucinating is also very well known. People, however, are so misled by the term AI that it came to a surprise to them that AI can misinterpret the meaning of words and phrases, as Timnit Gebru mentioned in her report, which she was writing when she was fired. But it should not come as a surprise. Comment from engineer on this is, of course it can misinterpret without ever realizing so. People still can't seem to grasp that the only misinterpretation is that it has anything to do with intelligence at all, whether artificial or natural. In fact, no intelligence, and therefore no misinterpretation and meanings whatever there. These models are just systems, quite complex, for processing raw data directly into a product entirely without any interpretations, meanings, and other crutches that humans with their universal but physically frail intellect use. Clearly, if such systems had a machine gun hanging from their output instead of harmless laughingstock attraction, then trouble is inevitable. And do you think that machine gun is a metaphor? Unfortunately not. As one internet user observed some time ago, not so long ago, the company that was making robots quickly went from dancing robots to mounted assault rifles on robotic dogs. Why this picture here? It illustrates the thought that it is very important to understand not only the technology, but also how this technology is used and to what effect. It is not guaranteed by default that wonderful technology will be used properly or will lead to human happiness. I prepared a little quiz. Those of you who will ever answer correctly, what does Dune movie? This is a picture from the Dune movie, has to do with the topic of this presentation, will get a prize from us. If you still have doubts, you can ask AI yourself, what is it? And no more discussion, AI has spoken. So one super important thing to remember for practical application of MT is that you need to review 100% of MT output for accuracy and meaning transfer, because this numerology trained by stochastic gradient descent method does not, it cannot by design and in principle check the meaning. Here on this slide you see on the left a very funny example of T9 in Ukrainian language. Notably, the quality of T9 does not improve and cannot improve. To the right is an example of text generation by Microsoft Office when the proposal is my previous emails. Well, I was going to write something completely different. As Rafaela Buchazo from Salesforce, a very advanced company in this regard, puts it, MT can say Thursday instead of Sunday or tomorrow instead of yesterday for no reason. It has hallucinations. We're not talking about human parity here, except for the segments that are not edited. Let's spell the difference between translation memory and MT technology. TEM can propose previously completed high-quality translations, including similar ones. 100% matches need to be checked much less if translation memory is good. Neural machine translation can create new word sequences that are not in the training corpus based on word usage in that training corpus. How well it does it is precisely what determines the quality of the model. But how this model does it has to be checked, and you need to be able to do this reliably. It's a mechanical process. MT does not analyze and does not check the meaning. Deep learning requires a very good model and vast amounts of good, clean data. The quality of the model drops quickly if the training corpus is dirty, incorrect, limited, or quality evaluation has been done incorrectly. Output quality depends on these and many more other situational factors and constraints. We already mentioned the reasons why the neural models have problems from scientific point of view. Here the problems are listed from linguistic point of view. We don't have time to run through all of the fundamental problems on MT here were visible to linguists, but roughly speaking, the problems of the technology are caused by its advantages. For example, fluency, which is often perceived as free manipulation with synonyms and using alternate words here and there, means there is a problem with terminology caused by the very design of the model. So one thing plays against you in a different situation. These problems are listed in detail in the article on our website with the link below, and there are more than 13 of them is going to be updated. Perhaps the most profound misconception is that a cheap, unskilled resource is sufficient for post-editing. This notion came from the times of statistical machine translation and is already obsolete. The reality is that post-editor of neural machine translation should check the meaning, follow the terminology. It is a must to review 100% of the material, verify accuracy of relaying the intended meanings of the source, because distortions of meaning and accuracy errors are often masked by literal translations. The post-editor must be a translator, which is mentioned in ISO 18587 standard. Translation services post-editing requirements, not the best standard, but still it says some right things. The post-editor must understand the subject matter area. You have to care for consistency, style, and language to ensure high impact. With neural machine translation, the post-editor must be experienced translator to realize productivity benefits without reducing the quality of results and translation memory, which is both a knowledge base and corpus. Now we have to review 100% and review very carefully. That is, the volume of editing as such has increased. Salesforce, a very advanced company, disclosed on the MT Summit last year that on average 36% of strings did not require any modification. Great result, but it is only a best case scenario, and you need to review all 100% and fix 74% of the content first in order to discover what that unedited portion is. This is not possible without significant human work. Linguistic similarity and semantic similarity are two different things, and this is one more reason why human editor has to review the MT output. In the upper left corner, you see the distribution histogram of human ratings. In the lower left corner, the same dataset is shown, its cosine similarity by Lapsi. We generated those charts from data from Google research study that we mentioned before. Humans see the meaning errors, while linguistic similarity only shows closed sentences. But even one comma can change the meaning completely, not to mention more serious things. Currently, there is no automatic algorithm to measure human perception of quality. In a nutshell, MT output looks great until you start reading it, but there is even more. Practical experience with Japanese translators in other languages is that even when translators rate the MT output as good and editable, they change their opinion to the worse when asked to read everything carefully, and even more as they ask to edit. Not because they are trying to edit more than necessary, but quite simply because when you edit, your review is more careful and attentive, and you see the problem when you encounter it. The analogy can be a plowman trying to prepare the field for seeding. Some of the stones you can see only when you are actually plowing the field. And then you need to stop work, take out the stone, and resume your work again. You can see many stones until you dig into it. Because there is no way to measure quality with automatic metrics with or without the reference translation, many are trying to base their decisions on edit distance metrics. It does sound plausible that the amount of effort the translator is making somehow correlates to the number of keystrokes needed to fix a given sentence. Unfortunately, this assumption also fails. Here on the chart, you see the plot of edit distance versus quality score for every sentence in a document of more than 100 sentences. Would you say that the straight line approximates this scattering? In my opinion, the straight red line is much more informative here because it says that fewer than 150 keystrokes will be enough to fix just about any sentence. The dispersions of sentence with high quality scores is really huge, and sentence with low quality scores also require low numbers of keystrokes to fix them. So edit distance tells us basically nothing about translation quality. It tells us about the effort to fix the MT output, but not about the translation quality. There are many things that can go wrong with neural MT, just like with any ML data science model. For example, blur is almost always inflated because the testing corpus is not cleaned correctly. This topic requires a separate discussion. We can get into the details of this due to the time limit, otherwise this presentation would take 3 hours, but you're welcome to get back to me on the issue of cleaning the text corpus and measuring the results of an MT. Both the issues very important, special techniques to do that, and of course you have to approach them with the correct technology, tools, and angle. And the fact is that if you can't measure quality of the output properly, you can't train and evaluate the model correctly, and therefore you wasted time and money because it is not clear at all how good is your model for your case and your content. Because even the best trained models are not precise, they always will produce errors. Proper training is quite important. Some root causes of incorrect training are incorrectly selected data. Domain IT is not a domain. This also requires explanation because from the point of view of human translator, the domain has much wider meaning than from the point of view of data science. For example, IT is a domain for human translator, but is not a domain for MT training. Because if you train your engine, let's say for Microsoft translation, it will not translate Red Hat Linux correctly because the terminology is different and even language is different. So IT is not a domain for data science. The dirty data using market available data led to the net degradation of quality. If you're using available data without properly cleaning it, you're probably not getting the improvement. Another problem of incorrect training is that overtrained to undertrained AI model, and for proper training, you need something more than just automatic metrics. You need a human evaluation as well. And of course, the main reason, one of the major reasons, is that incorrect quality metrics is used, inflated blue score, not reflecting the real quality of the model. It is a well-known fact that AI ML-based applications are difficult to implement and deploy in production. 80% of all AI implementation projects fail, and the reason is the complexity of these technologies. Big data are required, clean and good data are required, training data cannot be empty results. Data processing tools and techniques are required. Data stewards engineers are required. Engineers and developers are needed. ML engineers and MLOps are needed. Solution and process architects are essential. You need to measure translation quality reliably. The myth that MT is a zero-cost business is quite widespread. That Google Translate is cheap and completely free, while the reality is stock models have clear limits, not to mention the data security. But custom models require lease of computing power, collection, management, cleaning of existing datasets, purchase of datasets, cleaning of new batches of data, quality verification, periodic training and retraining, cost of in-house team of ML engineers, MLOps, team and programmers, special linguists, complex methodological and practical work on quality control, maintaining the model, and not to mention expensive subscription. All this is a lot of money. That's because the question of ROI is raised more and more in discussions about the MT implementation. Ford last year signed a service contract with Google and no longer trains its own model. It's now forbidden for Ford under the contract with Google. To improve the situation with quality measurement so as to measure the quality of machine output more accurately, we ported HLeopard to Python and published it, allowing everyone to use it. We also did something that no one has ever done before. We implemented the ability to train CacheLeopard on language pair using reference data, making it more accurate. Here's our poster for WMT21 shared metric tasks, which demonstrates that trained CacheLeopard has much better correlation with human judgment than Blur. There are many complexities and subtleties that you need to know, understand, and overcome in order to get good results. An organization that plans to implement this technology must have not only project managers, translators, and editors, but also software developers with very specific profiles. 3 bottom rows is what we always needed, 2 top rows is what is needed today, in addition to what we had before. So hopefully now you will see that the statement from an MT provider, most of the translated text don't even need to be edited. You can see the problem with this statement. Of course, everything has to be reviewed and edited. The best practices of Salesforce presented on MT Summit this year disclaim this statement. The pie diagram on this slide demonstrates the LogiPM quality profile, tells you exactly how much is to be edited in the MT output. It is a very clear profile. We are ready to share this methodology and approach with all the interested parties, and I will demonstrate and present this methodology in the upcoming Gala conference at the end of the next month. In a new study, which was presented last summer on MT Summit, researchers from Karlov University in Prague have repeated experiment initially conducted by Philippe Cohen on SMT engine, where they used a series of SMT engines with degraded quality to measure the gain of post editors. In the initial experiment, a clear linear dependency has been found. The better blow of an engine, the less time is needed for editing. The experiment was carefully repeated with neural MT engines, and important conclusions were made. We did not find any significant relationship between the produced output quality and MT system performance. Translating from scratch was not significantly slower than post-editing. The link between MT quality and post-editing time is weak. Compared with post-editing of SMT, post-editing of NMT is much more difficult. NMT does not demonstrate post-editing improvement with increase of blur. Fluency hides errors of meaning and does not correlate with adequacy. need to verify accuracy errors, which are hidden traps. Post-editing of NMT is mentally much more challenging than editing human work or SMT. Light post-editing does not make any sense because text is already fluent beyond that translator. Editor must be subject matter expert and have good command of language to be able to fix literal mistranslations. Publishing unedited NMT may lead to damages and legal consequences, is detrimental to the brand. Translator deals with black box with many unknown variables: quality of the training data, quality of the model, lack of ability to improve or even diagnose problematic patterns. As a result, the resource requirements for NMT post-editing have to be good translator with SME reviewer skills, good editor. It is true that overall productivity increases, but not that much, and the resource requirements are getting more demanding. We meet the last mile problem again. The consequences of under-editing, as Arlo Lamel puts it, are the parrot problem rears its head. Those who will not pay proper attention to the translation quality will have no more good TMs. There won't be data to train model with. TM technology will stop providing benefits. You will have to check everything, no longer skipping 100% matches. Errors will accumulate, the need for editors will only grow. To prevent this from happening, you still need to work with professional translation service provider, and now you have to read 100% and read carefully. The net volume of editing has increased. There is also a problem of data. As Common Sense Advisory calls it, 3C: collection, cleaning, curation. It is not enough to just collect translation memories. The data needs to be taken care of, cleaned, quality assessed, matched by domain areas, etc. Previously, we could sit idle on translation memories. Now we have to do a lot of work with them, and it is a new cost, new requirements, new tools, and new skills and labor. We have released, by the way, a new product that doing just these things. I'm sure other products will also enter the market. One of the implementation difficulties is low volumes of good training data available. As one machine translation provider puts it, most of the customers come with small data volumes. A minimum of 1 million bilingual pairs are required to train a custom engine from scratch. That's quite a lot. Not everyone has that many. About 400,000 pairs are needed to prime a baseline model. In this case, if you are priming the baseline model, the fluency is worse. The alternative is to translate training corpus manually or use the stock engine and carefully post-edit. Out-of-domain post-editing requires skills and effort. Here's the plan for another 60-minute presentation: risks for clients. Truly huge cost of ownership or subscription. The areas of applicability have to be clearly defined. You have to change processes, and this is far from easy. Fluency can be good in 40-70% of the output, but you need to check 100% for accuracy. No post-edited training. Under-editing is a typical problem. Meaning transfer is not verified. Exaggerated quality expectations due to improperly trained engine. Incorrect metrics to measure output quality. Priority of speed over quality leads to having no more good training data. Change priorities, shoot yourself in the foot. Good translators and editors running away like from fire. Commitment and quality suffers. There is one more thing which is not listed on this slide. I will probably add it later, is that you have to retrain your engine following the short cycles, let's say at least 3 months, which is very, very good. Most of the companies can only do this 2 times a year. So, because this is a technologically challenging effort as far as machine training process is concerned. I mean, data preparation and everything that comes with it. And of course, last but not least, is that risk management is essential when published on edited MT. And here are the references for you to read about risk management in translation in more detail. The consequences of the technology for LSPs are that price pressure across the entire services spectrum increases, including post-editing. The LSPs are also imposed on tighter deadlines imposed upon them. Those who want to develop these technologies will have to spend a lot of money. Mastering this technology will make much more time and money than translation memory. And there is a resource crisis. The number of experienced translators and editors will decrease and the need for them will only grow. So what's the conclusion? Finally, we do have the last slide here. The conclusions that the business of translation and IT is now blended together, and we are 10 levels up in the game generally. This technology requires building complex solutions which revamp processes completely, require new skills from language and engineering professionals, impose new requirements, call for new professions, and new and higher skills, new tools require significant investments and resources, as well as deep understanding of this technology and its application. Objective view and new skills and approaches will help. Thank you for listening. I appreciate your time. Please do not hesitate to get back to me with any question on any of the slides. I'd be happy to do a one-on-one session face-to-face through a teleconference or by email about the questions, your situation. Please come back with your data, your views, your comments, your facts for the future discussions and research in this area in the future version of this presentation. Thank you very much. Goodbye.